Friends, JWST has spotted hundreds of strange, compact, and extremely red objects that existed less than a billion years after the Big Bang. These ancient cosmic anomalies defy our standard model of galaxy and black hole formation, leading some astronomers to call them the universe breaker. Therefore, in this video, we will dive deep into the groundbreaking new model proposing that these tiny red dots are not dusty galaxies, but a completely new class of objects, a supermassive black hole shrouded in dense shell of gas. Therefore, join me on this cosmic journey. We will explain the extreme redness and the power of these early objects. Let's go. Look closer. It's one of the breathtaking view humanity has ever achieved, a window into the earliest moment of our universe. And thanks to the James Webb Space Telescope, you see countless galaxies, each a sprawling city of stars, but among them there are tiny, unassuming specks. The faint red, almost invisible. These aren't just any dots. These tiny red dots have baffled astronomers, hinting at a cosmic secret, a potential monster lurking in the dawn of the time. For decades, we have peered into the distant universe, trying to understand how everything began. Further out, we look further back in time. We see, and now with the incredible power of the James Webb Space Telescopes, we are seeing light from the galaxies formed a few hundred million years after the Big Bang, a time when the universe was barely in its infancy. This is an era of cosmic first, the first stars, the first galaxies, the very building block of the cosmos we know today. But among these nascent wanderers, JWST started spotting something unexpected. As JWST meticulously charted these ancient skies, a peculiar pattern emerged. Astronomers kept finding these small, extremely red objects. They were incredibly faint, indicating they were very, very far away, meaning they were very old. Their redness wasn't just a trick of the light. It suggests something fundamental about their composition or what was happening inside them. At first, scientists weren't sure what to make of them. Were they extremely dusty normal galaxies or something else entirely? They just didn't fit neatly into existing model of the early universe, and therefore they were called as anomalies. To understand the mystery, let's briefly talk about the color in space. The redness of a distant object can tell us two main things. First, they are redshifted. As the universe expands, light traveling from distant galaxies gets stretched, shifting its wavelength toward the red end of the spectrum. This tells us how far away and thus how old an object is. These tiny red dots showed extreme redshift, but there is another kind of redness which is attributed to dust. If any object is heavily obscured by dust, the shorter, bluer wavelength of light are scattered away, leaving only the longer, redder wavelength to reach our telescopes. Think of a sunset where the sunlight passes through more atmosphere and dust, appearing red. Could these tiny red dots simply be very, very dusty young galaxies? And that was one of the leading theories. While the dust certainly plays a role in making things appear red, the extreme redness of these specific dots presented a problem. To be that red, these galaxies would need to be astronomically dusty, perhaps even more dusty than we would expect for such young small galaxies. And even if they were that dusty, their observed properties still didn't quite line up with our best model of early galaxy formation. There seems to be hiding something fundamental, something extremely powerful beneath the layers of obscuring material. The dust theory felt incomplete. And this is where the groundbreaking new theory emerges, proposing a truly extraordinary explanation. What if these tiny dead red dots aren't just dusty galaxies, but instead represent an entirely new class of cosmic objects, a cosmic monster of sorts? This new model suggests that at the heart of each tiny red dot lies a supermassive black hole, far more massive than we might expect for such an early epoch. But here is a crucial twist. This black hole is completely enveloped, shrouded in an incredibly dense shell of gas and dust. Imagine this. Inside that dense shell, the supermassive black hole is actively feeding matter spiral into its terrifying grasp, forming an incredible hot, brilliant accretion disk. This disk emits intense radiation, X-rays, ultraviolet light, visible light. It's a cosmic beacon shining with unimaginable power. But because of that incredibly thick, dense shell of gas and dust surrounding it, almost all of that intense high energy light is absorbed by the shell itself. What happens to all that absorbed energy? The dense shell gets superheated, and like a cosmic oven, it radiates that energy but at a much lower wavelength, specifically in infrared spectrum. This infrared light is much less energetic, and crucially, it can escape through the dust and gas much more easily than the original high energy light. When JWST, which is specifically designed to see in the infrared spectrum of this light, these object appears as those incredibly faint, deep red, tiny red dots. They are not just dusty; they are the cocoons of black hole activity. This theory isn't just a clever explanation for some red dots. It represents a potentially entirely new population of cosmic objects. We are familiar with the bright, blazing quasars, supermassive black holes actively feeding, often spewing out powerful jets visible across the vast distances. But these new cosmic monsters are the opposite, quite shrouded and sort of hidden. They could be a missing link in black hole evolution. Perhaps more supermassive black holes started their life this way, hidden beneath dense shells, before eventually blowing away their cocoon and becoming active quasars we see later in the universe's history. This implies, as far as widespread and early presence of supermassive black holes than previously imagined. That means there were many more than we can count today. If confirmed, this theory profoundly changes our understanding of the early universe. It suggests that the supermassive black holes might have been even more common and influential in the formation and evolution of very first galaxies than we thought. They weren't just passengers, they might have been architects, hidden engines driving cosmic evolution from the shadows. Future observations with JWST, using its incredible spectroscopic capabilities to analyze the light from these objects in even more detail, will be very crucial. Astronomers will be looking for specific spectral fingerprints that can confirm the presence of these dense gas shells and the active black holes within them. So the next time you see one of these breathtaking images from the James Webb Space Telescopes, remember these tiny unassuming red dots. They are not just speck of light, they might be the glowing ember of the hidden cosmic monsters, supermassive black holes veiled in dense cocoon, silently shaping the universe in its infancy. It's a powerful reminder that even with our most advanced telescopes, the cosmos still holds unimaginable secrets waiting to be unveiled. So, friends, what do you think about this potential new class of cosmic monsters? Let us know in the comments below. And if you want to keep exploring the incredible discoveries from JWST and beyond, make sure to like this video, subscribe our channel, and I like to say goodbye. Thanks for joining me live. Until next time, keep looking up, keep exploring.